Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have links to online seminars and study manuals for exams P, FM, IFM, and LTAM that I teach. They all refer to BTDT, which is the name of the brand under which I publish my study manuals. It stands for Been There, Done That. This is what you need to be able to say every time you look at a problem when you take a test, when you take an actuarial exam. You look at the problem and you need to know immediately what to do, which means that you have done this kind of problem many, many times. You should do all the possible problems that can appear on the test in at least tens, if not hundreds. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible, to the extent allowed by law, donation to our actuarial program to help our students, please go to smarturl.it/help-ISU-actuary. Here's the problem for today. The moment-generating function of a random variable x is m sub x of t equal to 1/4 plus 3/4 times 1/1 minus t for t greater than 0. Calculate the excess of probability that x is greater than 3/4 plus square root of 15/2 over its best upper bound given by the two-sided Chebyshev's inequality. So Chebyshev's inequality, two-sided version of it, is on the test. You need to know it. And the one-sided Chebyshev's inequality is not on the test. Well, recall that the moment-generating function of a mixed distribution is a weighted average of MGF. So MGF stands for moment-generating function of the pieces of the mixture. Also recall that the MGF of the exponential distribution with parameter lambda is m sub t of u equal to lambda over lambda minus u, for u less than lambda. And so with lambda equal to 1 and for u less than 1, m sub t of u is equal to 1/1 minus u. Well, this looks familiar if you look at the MGF given in the problem, but not exactly what we want. Consider a mixture of a degenerate random variable w, where probability of w equal to 0 is 1. So it's a point mass with probability 1 at 0, with weight 1/4, which is 0.25, and t exponential with lambda equal to 1, with weight 3/4. Note that m sub w of u is equal to e of expected value of e to the uw, so it's the expected value of e to the 0, so it's 1. So that degenerate random variable has MGF equal to 1. So we see that x is equal to w with probability 1/4 and t with probability 3/4. So x is a mixture of this discrete degenerate random variable and the exponential random variable with hazard rate of 1, which also means that its expected value is 1. And therefore, the expected value of x is equal to 1/4 times 0 plus 3/4 times 1, because the degenerate random variable concentrated on 1 has the expected value of 1, and the exponential has the expected value of, has the expected value of 0, and the exponential has the expected value of 1. And that's equal to 3/4. Also, the second moment is e of x squared equals 1/4 times 0 squared plus 3/4 times, what's the second moment of t of this exponential random variable? Well, its second moment is equal to the square of the first moment plus the variance, and exponential with mean 1 has a variance of 1. So this is 1 squared plus 1, which is 2. 2 times 3/4 is equal to 3/2, and so e of x squared is 3/2. And the variance of x is therefore 3 halves minus square of 3/4, which is 9 over 16. So that's 24 over 16 minus 9 over 16, which is 15 over 16. And the standard deviation is the square root of that, which is square root of 15 over 4. Because this random variable is non-negative almost surely, with probability 1, that is, almost surely means with probability 1, the two-sided Chebyshev's inequality with r equal to 2 implies that 1/4, which is 1 over 2 squared, so 1 over r squared, is greater than or equal to the probability that x minus 3/4, the mean, is greater than 2, that parameter r, times the standard deviation of a square root of 15 over 4. So that's the probability that absolute value of x minus 3/4 is greater than square root of 15 over 2. And that's equal to the sum of probabilities that x is less than 3/4 minus square root of 15 over 2, plus probability that x is more than 3/4 plus square root of 15 over 2. Well, the first probability is 0 because this random variable is non-negative. And that number 3/4 minus square root of 15 over 2 is negative. Plus the probability that x is more than 3/4 plus square root of 15 over 2. So we get the estimate that 1/4 is greater than or equal to the probability that x is more than 3/4 plus square root of 15 over 2. That's the estimate given by the two-sided Chebyshev's inequality. So, again, probability that x is more than 3/4 plus square root of 15 over 2, less than or equal to 1/4, is the best upper bound estimate for this probability provided by the two-sided Chebyshev's inequality. The exact probability, well, we can find it because to be more than 3/4 plus square root of 15 over 2, the random variable has to be in its portion that is exponential, which happens with probability 3/4. Because if it's degenerate at 0, it's less than this number 3/4 plus square root of 15 over 2. So this is 3/4 times the probability that t is more than 3/4 plus square root of 15 over 2. And that probability by itself is given by the probability of the exponential portion of the random variable, which is hazard rate of 1. So that becomes simply 3/4 times e to the minus that number, 3/4 plus square root of 15 over 2. And we calculate this to be 0.0511, and 0.0511 minus 0.25 is negative 0.1989, which is answer E. And by the way, it's interesting to note that if we use the one-sided Chebyshev's inequality, which says the probability that x minus mu is greater than or equal to k times sigma, the standard deviation, or the probability that x is greater than or equal to mu plus k sigma is less than or equal to 1 over 1 plus k squared, with mu equal to 3/4, sigma equal to square root of 15 over 4, and k equal to 2, we get a probability that x is more than 3/4 plus square root of 15 over 2 to be less than or equal to 1/5. And that's instead of 0.25 that we had before, so it's 0.2. So 0.0511 minus 0.20 is negative 0.1489, approximately answer D. But one-sided Chebyshev's inequality is not covered on exam P1, while a two-sided is, and we stay with answer E. And I give you this problem because the two-sided Chebyshev's inequality is on exam P. You need to know it. You need to memorize it. So please make sure that you know it. Of course, it's covered in my study manual, which you should get. And you can get it at smarturl.it/btdt-p. And I hope you enjoy it. Please remember this is copyrighted material. This problem was created by me and the solution is mine. All rights reserved. The reproduction in whole or in part without express written permission from the author is strictly prohibited.